Two of these triangles. I'm going to pull out A, B, F. So that is my A, B, F. Then I'm going to pull out the other triangle, which is A, C, E. Now what I want to look back at is the picture. The picture says angle B is equal to angle E. So angle B is equal to angle E. Do you see angle A? Isn't angle A the exact same angle here as it is here? So if this is 65 degrees, this one's 65, and this one's also 65. So because of the exact same angle, we know that A has to be equal to A. Now, what's the measure of every single triangle in the world? 180. So if this equals 40 and 50, and this one equals 40 and 50, doesn't C and F also have to be congruent then? I'm going to say that one more time because some people weren't paying attention. If B and A is the same as E and A, then both of our C and F have to be congruent because they have to add to 180. So my example is, if B is 40, that would make E 40. If A was 60 degrees, this A would have to also be 60 degrees. And if this is 60 and 40, this has to be 80. If this is 60 and 40, this also has to be 80. So if you know two angles of two separate triangles are congruent, that third angle also has to be congruent. All right, just through the basics of it being 180 degrees. Well, that'd be another example of kind of like a corollary. All right, questions on that? Yeah?
So you're saying A and E are equal? Or?
No, I'm saying B and E are equal because they told me that. But A has to be the same as A because it's the same angle. If this is 60 degrees, then this has to be 60, and this has to be 60. Which means that third angle must also be congruent. Questions on that? That's a big thing to know. That's a big thing to know and being able to pull out triangles. That's going to be a key to helping you on some of these problems, actually drawing two different triangles. All right. Today we're going to talk about polygons. A polygon literally means many angles. Just means many angles. A polygon is formed by coplanar segments called sides. Remember, sides are going to be segments. I'm going to say that once again. I'm going to put up on there, even though it starts with so if I ask for the side of a polygon, you better give me a full segment. All right, each segment intersects exactly two other segments, one at each endpoint. No two segments with a common endpoint are collinear. That means you don't just have a giant straight line. So these are all examples of polygons. These all have sides, and if you look at every single side, it connects with two other segments. So like this side has a segment on this end, and this one has a segment on that end. These are all examples of non-polygons. Those are non-polygons. The first one can't be, because we have a straight line is connecting one, is touching at this segment, is touching at that segment. So you can't have any overlap. So that is the problem with this one. That is not a polygon. This one's not a polygon because that's not a segment, that's a curve. And the last one isn't a polygon because it's not intersecting at exactly two other segments. This segment right here only connects to ones on this side, not on the other side, because it has to be two other segments, one at each endpoint. These all have endpoints that aren't connected to something. So these are definitely not polygons. And don't worry too much about not polygons. Everything we're going to deal with are polygons. On the test, I'm not going to say decide whether this is a polygon or not. All right, so I'll basically give you a polygon, and then you have to discern information from it. But it's good to know what is and what is not a polygon. All right, convex polygon. A convex polygon is basically the ones we're going to work with. And that is a polygon such that no line, let's go back to black, containing a side of the polygon contains a point in the interior of the polygon. So this is a convex. All of our vertices are pointed outwards. This is a concave. These vertices are pointed inwards, or point to the inside. Everything we're talking about in this class is going to deal with convex. So this is your major one. When I talk about a polygon, I am specifically meaning convex. So if I say polygon, you're going to automatically picture convex. Unless I specifically draw one that looks like that. All right, so convex, that's really the one I want you to focus on. That is the drawings we're going to do. Those are the pictures we're going to do. All right, polygon classifications. Polygons are classified according to the number of sides. And the terms that we apply to triangles, such as vertices and exterior angles, also apply to other polygons. So that's just a note. All right, so if you have three sides, we call it a triangle, because tri means three angles. 4 is a quadrilateral. Quad means 4. Quadrilateral has 4 sides. 5 is a pentagon. Penta means 5. 6 is hexagon. 7 is heptagon. 8 is octagon. 9 is nanagon. 10 is a decagon. 12 is a dodecagon. And basically anything past that, some of them have names, but you can just say like a 13gon, a 14gon, a 15gon. Yeah, well. You won't have to memorize them, but you should know a couple key ones like hexagon, heptagon, octagon. You should be able to, if I say it, you can kind of picture what they are. Yeah.
What about 11?
I forget the name on that one, but it's a weird name.
11. Is it like ondagon?
It's like ondagon or something. Yeah, it's something that doesn't really represent. It's weird. It's one of those weird ones. 13 has a name. 20 has a name. All of them have a name pretty much up to 20, but they get really dicey. These are the main ones that you need to kind of recognize and see. Those are the main ones you need to recognize and see. But worst case scenario, you just put 8gon. All right, if you don't know the name of it, just put 8gon if you don't remember octagon. If you don't remember, I don't know, hexagon, you could put a 6gon. But those are good to just know. It makes your life a little easier, Will, versus having to switch back to that sheet in homework. All right, when referring to a polygon, we are going to list things in a specific order. We're going to list consecutive vertices in order. So we're going to go consecutive vertices in order. And what I mean by that is you're going to pick a starting point, and then you're going to work around either clockwise or counterclockwise, naming everything in order. So let's start at D. So if I pick D, I'm going to go around in that order. So I'm going to call this pentagon DCBAE. Or you could go the opposite direction. You could call it DEABC. Or you could pick a different starting point. You could pick C. If I pick C, I could go C, B, A, E, D, and there's a ton of different possible options. The only thing you can't do is skip around. You can't call this like C, A, D, E, B. All right, it has to go either counterclockwise or clockwise. But you can pick any letter to start off with, just as long as you go counterclockwise or clockwise to pick the rest of your letters. Is there construction today? All right, diagonals of a polygon. Diagonals of a polygon are segments joining two non-consecutive vertices in a diagonal. So these are segments joining two non-consecutive vertices in a diagonal. All right, so my example there connects A to D. We could have a diagonal connecting A to C. You can't have a diagonal connecting AB or EF. Or AE, sorry. I thought that was an F for a second. So they have to be at least one away. So two non-consecutive vertices. And how you'd write that, if you wanted to specify this, you would say that's diagonal. And you name it as a segment. So that'd be diagonal AD. So diagonals will be segments as well. All right, the last thing we're going to do is talk about the sum of measures of any polygon. What's the sum of angles of a triangle? Yeah?
No, 180.
180. Yep, there you go. So the sum of angles are 180 degrees. Note that we have three sides, and in this picture there's one triangle. Seems pretty ridiculous to say there's one triangle because it is a triangle, but we're going to build to something. All right, our next one. Our next one is quadrilateral. It has four sides. If I draw one, just using one diagonal, I would have two triangles that none of them are overlapping. My angle sum is going to be, 360 degrees. So just note that's 2 times 180 degrees. Yeah. How would it be three triangles? Say that again?
So you go from the side and cut it in half.
I go from the side and cut it in half?
No.
Can you just point to it?
Yeah, you go from this side.
Down here?
Never mind.
Because then they overlap. I'm just looking for two triangles that do not overlap and that deal with these angles here. The only way to do it is just with one line creating two triangles that occupy just the vertices. All right, our next one has 1, 2, 3, 4, 5 sides. And just from one vertice, I would have 1, 2, 3 triangles. And each of those triangles cuts one vertice and they don't overlap. So what's the angle sum of this one? If I have 3 triangles, what's the sum of this one? Like 540 degrees. Or in other words, you're just going to go 3 times 180 degrees. On our final one, it has 1, 2, 3, 4, 5, 6 sides. If I pick one vertice, I can draw 1, 2, 3, 4 triangles. Each of those triangles is just one of the vertices, and none of them are overlapping. So I can draw 4 non-overlapping triangles. So our angle sum of this one is going to be 720 degrees. Or you can just do 4 times 180 degrees. I just want to note something, because this is pretty big. This is going to be a huge thing that you're going to use over and over and over, so pay attention. 3 sides is 180 degrees. In other words, 1 times 180 degrees. 4 sides is 2 times 180. 5 sides is 3 times 180. 6 sides is 4 times 180. Does anyone want to try to do the pattern for something that has 7 sides? If I had 7 sides, what would I do to get that measure? Yeah. It'd be 5 times 180. Could someone tell me the measure if it was 10 sides? What would 10 sides be? Yeah.
8 times 180?
8 times 180. What if I had 100 sides? What if I had 100 sides? Yeah. 98 times 180. So if you know the number of sides of your polygon, you actually know the sum of the interior angle. And that comes to the sum of interior angles. The sum of the measures of the angles of a convex polygon, which is all we're going to do, which is n sides, is, does anyone want to help me out here? What do we do with the sides first? What did I do when I had 5 sides? How do I get from 5? Yeah. N minus 2. Perfect. It's going to be n minus 2. And then we just multiply by 180 degrees. So, a 20-sided polygon would be 20 minus 2 times 180 degrees, which would be 6,480 degrees. And that would be the sum of the angles. And it would be the number of triangles, yep. So if I ever forget this formula, I just go back to drawing a triangle, and then I draw a square, saying it's one triangle, and a lot of times I can just do those two and remember that formula again. It is your number of sides minus 2 times 180 gives you the total sum of all of your angles. Interior angles, I should say. Questions on that? All right, if there's no questions on that, what questions do we have from the homework? Oh, I did have one more slide, I guess. I didn't actually put it on here. There's one more page that says polygons can be equiangular or equilateral. Let's go ahead and put that. That's actually kind of important. I don't know why I put it over there. It's on the next page. I just went over one page, I guess, to get it going. That is an important term. I don't want to skip over that. And that is the word regular polygon. A regular polygon means polygons can be equiangular or equilateral. If a polygon is both equiangular and equilateral, then it is a regular polygon. So a regular polygon has all congruent angles and all congruent sides. So if I ever say it's a regular hexagon, you know that all the angles are congruent and all of the sides are also congruent as well. That's a big word to know. Regular polygon. Everything's equal. All right, homework questions. What questions do we have from the homework? So that would have been 3.3b. No, I'm sorry. That shouldn't be 3.3b. That should have been, 3.4. Let me get that out. All right, no one has questions. Show the record that no one has questions.
Could you go over number 29?
Yes. I absolutely can go over 29. Now, everyone should pay attention to this one, because I'm fairly confident that several of you did not get these. 29. The most important part about 29 is the setup. The actually solving it is worth the least amount of points. All right, Sage?
Yeah.
So we see we have x and y's, which means I need two equations. I need two equations. So we're going to set up a way to get two equations. So the first thing I'm going to look at is, you see this linear pair? What does a linear pair have to equal? Yeah.
I don't know.
What is a linear pair? What does this have to equal if it go over?
180.
180. So I know 125 plus 2x plus y has to equal 180. So that's the first thing I wrote down. That is my first equation. Now I need one more equation. And I note that this is an exterior angle. So we kind of have two different equations we could write. We could first write, see how this is 125? And remember, if it's an exterior angle, it's going to equal the sum of the remote interior angles. So I can go 90 plus x plus 2y equals 125. Do you agree with that, or did I lose you? Oh, okay. So this is an exterior angle, right? We're okay with that?
Yeah.
And if that's my exterior angle, then these two are my remote interior angles, because they're the ones farthest away. Well, if you add your two remote interior angles, it has to equal your exterior angle. So that's why I did 90 plus x plus 2y has to equal that 125. Sage, there's one more equation you could have done. You also could have said this plus that equals 180, because every triangle equals 180. So those are three different equations. You only have to pick two. I picked these two. I used the remote interior and I used this. This is worth the most points on this. All right, so if you really struggle solving these, it's not the end of the world. On a test, don't panic because you don't know how to solve it. Just set it up as best you can and tackle it as best you can. Don't waste 5 minutes on this problem. I'm just going to write it so my x's and y's are in the same place. And I'm going to use elimination to solve. To use elimination, you need to have a zero pair. So see how this is a positive 2x? I need to have negative 2x to create a zero pair that's going to cancel out. Well, to make this negative 2x, I need to multiply this by negative 2. But that just means I need to multiply this entire equation by negative 2, and I'm okay doing that. All right, as long as you do to everything, everything stays equal.
Where did you get the 35?
35, I just, remember how I had the 90 on this side?
Okay.
I just subtracted it.
Okay.
So I simplified and put my x's and y's above each other. Well,
Are you multiplying everything by negative 2?
so I'm going to use elimination. Remember, we have two methods to do this. We can either use substitution or elimination. Elimination, you have to have a zero pair, or a pair when we add both these together crosses out. So this is 2x. The zero pair to 2x would be a negative 2x, because 2x plus negative 2x equals 0. The only way to make this into a negative 2x is to multiply everything by a negative 2. All right, then we come down here. I distributed that negative 2, which left me with that negative 2x. Negative 2 times 2 is a negative 4y. 35 times a negative 2 is a negative 70. Now when I add these two equations together, my 2x minus 2x cancel out. I'm just left with negative 3y equals negative 15, which gives me y equals 5. Now that you have y equals 5, you just take that 5 and plug it into either one of your equations to solve for x. But once again, your most important step is this one right here. This is worth probably 3/4 of the points that you can set this up. The extra point or point and a half would be attempting it and then successfully solving it. Yes? Yeah. Any more questions on 29?
So would number 30 be kind of the same?
30 would be almost identical where you have to set up two different equations.
Okay.
And you're going to use the fact that there's two parallel lines, so you can use like alternate interior. You can use same side interior to come up with one. Or you can use the fact that it's a triangle, so it has to add up to 180. Okay? You want to give it a shot?
Yeah.
All right. And then you said number 17? All right. This is not number 17. Number 17 says the length of the sides of a triangle are 4n, 2n plus 10, and 7n minus 15. Is there a value n that makes the triangles equilateral? Hint, all angles must be equal, right? To be equilateral. So all you had to do is just set two of the angles equal to each other. So I picked 4n. I'm going to set that equal to 2n plus 10. And then I solved it. So I have 2n equals 10. So n equals 5. Now what you have to do is make sure all of the angles are actually congruent. So we have 4n. We have 2n plus 10. And we also have 7n minus 15. What you need to do is you need to take that 5 and plug it in for all of your n values. 4 times n is 20. 2 times 5 is 10 plus 10 is 20. 7 times 5 is 35 minus 15 is 20. It is equilateral because all your angles are 20. Or I mean, all your sides are 20. I'm sorry. I don't know what I was talking about angles. All right, other questions? Other questions on the homework? All right, if there's no more questions, the rest of the time is yours to work. I am going to check your homework because I knew there was going to be a question about those last two, 29 and 30. Sage, I hope that's enough to at least start 30. And then you can look at the answer guide and see if it kind of makes sense. You were just stretching, right?
No, I was there.
Oh, okay. Yeah. Sorry.
No, I got it.
Can we use our
You
calculators?
sure? Yes. Yeah. You can use your calculator. On the test, you can use your calculator as well.